In this section, we're going to talk about the volume of right prisms and right cylinders. Volume is, think about this cube that you see in this picture, this cube right here. If you poured water inside it, that would be the volume of the water, and volume is measured in cubic units such as centimeter cubes, inches cubed, meters cubed, etc. A cube has all congruent sides, and it's a special right prism. We will only be talking about right prisms in this sections versus oblique prisms. Oblique prisms are tilted. These are pyramids, and it's stating the obvious that if two polyhedra are congruent, then they have the same volume. The same would hold true if you had, prism shaped objects. A volume addition postulated, that's what it's saying is if you have let's say cylindrical top, and then you have a rectangular base, and this is a three-dimensional figure. I'm not very good at drawing three-dimensional figures, but imagine a three-dimensional figure, okay? Something like that. So that would be the top. This is terrible, but never mind. You would just add the volumes of the rectangular prism to the volume of the hemispherical top. It's a good thing I'm not taking art classes, but you just add the two volumes. I think that's pretty obvious. Okay. Prism again. Now, this is very interesting, and I'd like you to pay attention to this. Normally, we look at a diagram, the base is, the height is vertical. In this diagram here, this is the height. Okay? This is the height, and the base is the triangle. So the two congruent faces, and which are parallel to each other, are the bases. So that's a base, and that's a base. In this case, to find the area of the base, you would use the formula for the area of a triangle. Note, this height is the height of the triangle. So let me erase that. So this is BH1. Okay? So always distinguish between the height of the prism and the height or the apothem of the base. Moving forward, volume of a cylinder. Hello. Okay. In a cylinder, we have a base just like we did for prisms. Two bases, they are parallel. Now, they may lay a cylinder on its side, and the bases would still be the two circular bases. So which is the height here? That's the height. And B, that's the base. And R is the radius of the base. So over here, it says the volume is always base times height, whether it's a cylinder or a prism. And when we say base times height, we use capital B for the area of the base. It's important to keep to pay attention to the case. Okay, problems. Find the volume of the right hexagonal prism or right cylinder. Right cylinder is the next problem. Each side is 12 centimeters long. The apothem is 6√3. This is the apothem here. Okay? So what you should do, and we seem to have this side sort of disappeared. that side. So what you want to do is to find the area of the base. That's a regular polygon, and you're given that, oh, and you're told this is 12 centimeters. So they've given you everything. So it's 6 root 3 times the number of the hexagon is 6 sides. Side length is 12 all over 2. Okie doke. Well, it's not such an okie doke. I moved on too fast. That's the area of the base, but find the you do B times H. Okay, so that should be pretty simple. Moving to cylinder, you're given the radius. That should be pretty easy. Area of base is pi r squared. 10 feet is the height. Okay. This got a little shifted. Let me see if I can move it. Anyway. Okay, this is the gift box. Right, move up. The volume is 108 inches. Find the length of one side. So look at your formula. V equals S cubed. Ask yourself, what is V? Plug it in. I want to remind you that on your calculator, to find the cubic, so if you wanted to find the cube root of 8, oh, I don't mean that. If you want to find, let's say, I'm just giving you an example here. Let's say the volume was 8 and you want to find S. So you need to find the cube root or raise both sides to 1/3 exponent. So the way you would put this in the calculator is you would say use 8, then the up arrow, and in parentheses 1/3. Check this out and should give you the answer too. If you got that, then use the same technique to solve this problem here. Okay? Oh, I guess that is the end. Okay, good luck with that.